In this question, we're told that a car of mass m is initially stationary on a smooth track at a distance h above the ground. The circuit comprises of a loop with a gap at its top, so we can see the gap over there. The line segments joining each end of the gap to the center of the loop make an angle of 45 degrees to the vertical axis. So we can say that that's a right angle. I'm just going to underline that. Calculate the value of h required in order for the car to complete the circuit by transversing the gap, so as to rejoin the track accurately on the left-hand side of the gap. You may neglect air resistance and take the exertion due to gravity as g. Right, so first of all, we would have to consider the energy changes. So the initial energy of the car would be mgh, as we already know. So that will be the gravitational potential energy. And this would equal, at this particular point, so this height, let's say that's h1, mgh1 plus a half mv squared. And the v would be the velocity at which it leaves this point, so the tangential velocity at this point, so v. Right, now first of all, let's find h1, then we'll focus on v. So for h1, we're given the angle as 45. If we do this, we'll know that angle is 45 as well. We're given that's the radius, so we can make a vertical. Right, so we can say that tan 45 equals, let's say x, this height, over the radius. R equals x over tan 45. Right, now we know tan 45 is 1, so we can say that this was r, so r equals x. Right, so let's just read out the initial equation. mgh equals mgr plus a half mv squared. Right, let's just cancel out the m's as well. So gh equals gr plus 1 over 2v squared. Now, to find the velocity, we need to look at the top, what's happening at the top. So let's make this separate circle. So that's our center, that's the radius, and we have another radius on the left side, so r. I'm going to make this line dotted to show that it's not actually passing through, it's just blank, right? Okay, so we have this, and then we're given that this angle is 90 degrees, or if we split it down the middle, is 45 and 45. So in terms of the velocity, at the point where it leaves the circle, let's say, it will have a tangential velocity v. So something like this, and it will have v. But there's always a force acting downwards due to gravity, so it's going to follow a curved path, so something like this. If we kind of expand on this on the side, we can see this as sort of like a projectile motion question. So let's just say this is the top of the journey, or actually let's just make it a bit more clean. Yeah, let's just say it's this, okay? And the radius, it looks like a parabola, but let's just say it's some sort of circle. So the initial velocity is v. This angle is some angle theta, which we can figure out later. And then it travels a horizontal distance of some value, say s. Okay, and we want it to meet at this point. So using these equations, we should be able to get a value for v. And we can figure out s as well. So let's figure out s first, and then we'll see about theta. So let's take this green pen. If I make a line there, that was kind of low. Right, let's just say it's this. Okay, we have a right angle triangle. So it's something like this. So it's right angled R, R. We can find this angle, this side. So this will be R squared plus R squared equals this side. So we can just say square root of this. So R root 2 is the length, S. So S equals R root 2. That's S and that's S. Right, now the angle. We need to find this angle, theta. Okay, we're given this is 45. So let me just use the highlight. This is 45. Okay, that would be 90. So in that case, this would be 45 as well. Because this is tangential, the velocity, this would be a right angle as well. So using these cases, we can say theta is also 45. So now we have these values. So theta is 45 degrees and S is R root 2. Using this, we can find an expression for the velocity. So let's see about the horizontal distance. So obviously in the horizontal plane, we will have acceleration equals 0. We would have a horizontal velocity of v cos theta, which would be vh, so the horizontal component. The vertical component of the velocity vv would be v sine theta. So to get a value, we can use s equals ut plus half at squared. So first we'll use it for the vertical case and then for the horizontal case. Or I think another thing we could do is use the vertical case first to find the value of t. So vertically, let's see how much time it takes to reach this top point, because at the top the final velocity in the vertical plane would be 0. So we can say v equals u plus at. So we have v equals 0, u equals I think it was v sine theta minus gt, because g is the force, the acceleration downwards. So we get an equation for t, which is v sine theta over g. So the actual time taken to cover this whole distance would be 2 times t, because it takes times t to cover this distance, and another time t to cover this distance. So actual v for total journey would be capital T, which is equal to 2v sine theta divided by g. I know we have a value of theta, so we'll sub that in later. Now if we look horizontally, we can use s equals ut plus half at squared. S equals ut plus a half at squared. A is 0 because it's in the horizontal plane. So we get s equals ut, or actually I should say capital T. So s equals u, which is v cos theta, and then t, which is 2v sine theta, 2v sine theta divided by g. Right, let's get v on its own now. So we can say that s equals v squared 2 sine theta cos theta divided by g. So v squared equals sg divided by 2 sine theta cos theta. Now we don't need to square root this, because in the original equation for energy we only need v squared. So now we can sub in some values, or actually let's sub enter back into the energy equation first. So our energy equation was this. Okay, so I'm gonna bring everything there. Okay, so using energy equation, which was GH equals GR plus a half V squared, and then we sub in V squared equals this, so GH equals GR plus a half times SG divided by 2 sine theta cos theta. Let me just double check that's right. Yep. So the g's can cancel throughout, and we can get a h equals r plus s over 4 sine theta cos theta. S equals, I think it was r root 2. So r root 2. Theta is 45. So sine 45 was root 2 over 2, and so was cos 45, root 2 over 2. So if we sub those back in, h equals r plus r root 2 divided by 4 times root 2 over 2 dot root 2 over 2. The 4's cancel with the 2. So h equals r plus r root 2 divided by root 2 times root 2 is just 2. So the final answer is h equals 2r plus r root 2 over 2. And that should be our final answer. Okay, so we made a tiny mistake in the trigonometry at the start. So we said that tan 45 equals x over r. But in reality, this radius is not complete because we're cutting this part out. So actually, we would have to do sine 45 equals x over r. So we would get r equals x over sine 45. Sine 45 we know is a root 2 over 2. So we could get x in terms of r actually. So x equals root 2 over 2 r. And the net height, so x plus this radius, because that's the radius, which we forgot to add as well. So the actual height, total height, would be root 2 over 2r plus r. Okay, so I could just rewrite that as root 2r plus 2r over 2. And we can just change this in the final equation. So at this stage, so root 2, what was it? Root 2r plus 2r divided by 2 plus r root 2 divided by 2. Right, now we can just add them together. So we get 2 root 2 plus 2r divided by 2, which is just equal to, r, root 2r plus r. So that's our final answer for h.